Okay, hi everyone. Welcome to Science and Society, the Philosophy of Disease second lecture for the 12th of October. I look forward to seeing you all in half an hour or so when I'll log on to Skype. Hopefully that will work well and I'll see you. Right, okay, so today we're going to go through just a recap on Christopher Borse's naturalist conception of disease, and then going to go through a number of objections and hopefully try to explain those clearly and give you a chance to edit your essays if you feel like you haven't quite captured what Borse was trying to say and what the objections were to his conception of disease. So remember, Christopher Borse was trying to provide a conception of pathological condition. That is to say, the view of disease that the pathologist has, where pathologists are the kind of people who receive tissues and cells and so on, just little samples that they can examine and attempt to determine what's wrong with those. Is there anything abnormal going on with those samples, with those blood samples, with that particular organ? So Borse's account really is an attempt at a value-free account, as opposed to say Cooper's account, which was an attempt at capturing the concept of disease of the clinician, where the clinician is more concerned with the values of the patient's desires, as well as whether or not the patient is suffering from any kind of pathological condition. Okay, so what I'm going to do now is just, hopefully this will work, I'm going to try and put a diagram on this video. Now, what you'll see is this sort of normal distribution, and the idea behind this is that the diagram represents quantities of some, could be some functional efficiency of an organ, tissue, cell, that kind of thing, across a population. Okay, I'll explain it in a bit more detail now. Just pay attention to this picture. Okay, so note on the y-axis, going up on the left-hand side, you've got the prevalence in reference class. Now, the reference class, as you should know from last week, if you've done the reading, is essentially a group of people, a group of the population, where that population is separated into age groups, sex, species type. And this is important because what is normal for one reference class is different to what's normal for a different reference class, and we shouldn't be judging whether or not an individual is diseased based on what's normal for somebody in a different reference class. So the example I used before was puberty. Okay, so if you've got a 23-year-old who's not gone through puberty, then that individual is not normal for his reference class, because most 23-year-olds have gone through puberty, whereas a 10-year-old, you wouldn't want to say that a 10-year-old was diseased when the 10-year-old hasn't gone through puberty, because it's perfectly normal for a 10-year-old not to have gone through puberty. In fact, if he had, then you would expect that 10-year-old to have some form of pathological condition, some form of disease. Okay, so the y-axis represents the prevalence in reference class, so that is the number of people within that reference class who have a degree of functional efficiency that is indicated on the x-axis. Okay, so let's use an example. Memory, brain functionality. So some people have very poor memories and some people have very good memories. On the far left-hand side of the graph there, on the far left-hand side of the x-axis, lie those members of the population with very poor memory. Right, those that remember virtually nothing are on the far left-hand side of the x-axis. The top of the bell curve in the middle of the chart there, that represents the average sort of memory. You know, a lot of people who have reasonable memories, memory, they don't remember everything, you know, they don't remember everything they see, but they're not all that forgetful, like someone like Alzheimer's, like somebody with Alzheimer's. No, they've got your sort of average memory, and that's why it's the top of the bell curve, because the prevalence of people with your average level of memory is, of course, the highest. It's the top of the bell curve. And then on the far right-hand side, sit people with extraordinarily good memories. Okay, people that have photographic memories, they remember absolutely everything. Now, of course, one doesn't have to have a photographic memory in order to be healthy. You don't want to set the bar, as it were, that high. You want the sort of normal amount of memory, or at least this is what Bohr says. You want the standard, bog standard, average level of memory to be an indicator of healthy status. Okay, so anyone that's better than the norm, they are all healthy, of course. Now, you can have slightly worse than average memory, so slightly left of the top of the bell curve, and still be fairly healthy. Normal does not mean precisely the average, right? It doesn't have to be exactly the top of the bell curve. Normal means within a normal range, okay? So somebody can have slightly less than average memory or slightly more than average memory. That's a sort of normal range, okay? Normal doesn't mean equal to or greater than the mean, right? The top of the bell curve. You can have slightly less and still be normal. Okay. So that's a healthy range. The shaded area on the far left, on the other hand, that shaded area, that's indicative of having a pathological condition. So if you're so far to the left of that x-axis, such that degree of functional efficiency is subnormal, that is below that sort of normal range, then you are diseased in this case with respect to one's memory. Now that line is interesting. I'll come back to this, but where one draws that line is a little contentious. I mean, you'll see that there's a statistical model that states that anything below 2 standard deviations from the mean counts as diseased. But that seems wrong, because there are diseases that lots of people have, such as gum disease, and there are diseases that very few people have, such as hypertrichosis. Hypertrichosis is the werewolf disease. People who grow absurd amounts of hair, all comes out of their face, that sort of forehead, very unpleasant condition to have. But not very many people have it. In fact, there's 10 or 20 maybe in the world. There's very few people. Whereas just under half the population have gum disease. So where one draws the line, how many people are supposed to fit into that grey area is difficult, and one of the objections that Bohr must face. So we'll come back to that. Anyhow, Bohr's view is that it's a biostatistical conception. It depends upon what the average functional efficiency of that physiological subsystem is. So what's normal what's a normal memory, and what's subnormal memory. And subnormal memory counts as diseased, and normal, or what I'll call supernormal, very good memory, that's obviously healthy. Okay, so that's Bohr's view in a nutshell. Right, so I just want to clarify a few things. Bohr's view is a naturalist conception, right? And by a naturalist conception, Bohr means that it's entirely value-free. So unlike Cooper's view, they're not interested in the desires, the judgments of the patient. It's just purely about what counts as normal what counts as subnormal. It's a statistical view. But this isn't always how it's portrayed, and I'm going to read something just now from Murphy that you will have come across if you decided to read the Stanford Encyclopedia, which I know a lot of you might well do. So Murphy writes, the naturalist conception of disease, perhaps most clearly stated in Bourse, is that the human body comprises organ systems that have natural functions from which they can depart in many ways. Okay, that's true. Some of these departures from normal functioning are harmless and beneficial, but others are harmless or beneficial rather, but others are not. The latter are diseases. So to call something a disease involves both a claim about the abnormal functioning of some bodily system and a judgment that the resulting abnormality is a bad one. Okay, so that's how Murphy characterizes naturalist conceptions of health and disease. However, that is not at all what Bourse says. Okay, Bourse's conception is entirely value-free. That's what Bourse means by naturalist, right? He means a theoretical notion that is value-free. There are others. There are other views that involve a value judgment. We looked at Cooper's. Jerome Wakefield's view also includes a value judgment. Jerome Wakefield's view is that there is a statistical conception, something about normal functioning, but there is also a value judgment side of it. But that's not naturalist in the same sense as Bourse. Bourse means there is no value judgment involved whatsoever. In light of this, a number of authors have criticised Bourse on the grounds that his view is in fact value-laden. That is to say, Bourse wants his view to be value-free, he wants his view to be naturalist in the way that he describes it, but he fails in that regard because his view is value-laden after all. A number of reasons. First of all, if you look at the reference classes, he picks out the criteria for the reference classes. So he picks age, species type, and sex as particularly important. Now, what the reference classes are and what conditions are set for being a member of a particular reference class has a serious impact on whether or not an individual within that reference class is diseased. So, for example, Kingma says, look, if Bourse had set a reference class to be people with Down syndrome, for example, then everyone within that reference class would have Down syndrome automatically. And so it would be perfectly normal, obviously, to have Down syndrome if the reference class was based on people with Down syndrome. In which case, Down syndrome would not be a disease because it's statistically normal to have it. Right. So purely in selecting the criteria for being for the reference classes of age, sex, and species type, Bourse is in doing that making a value judgment, and in this regard, his view is not naturalist after all. Okay. Similarly, Bourse chooses survival and reproduction as the natural goals of organisms. Okay. So one determines how well a physiological subsystem is functioning based on its contribution to survival and reproduction. But how does Bourse get to choose the goals of an organism? I mean, we have plenty of goals, right? My goals include more things than survival and reproduction, right? I want to write good philosophy. I want to get a nice big house somewhere. I'd really quite like my visa. Okay, so I have goals that include many things over and above just survival and reproduction. So, isn't Bourse making a value judgment in choosing the goals of an organism? And if he's choosing the goals of an organism, then in essence he's choosing. He's setting the criteria for how well a physiological subsystem is functioning, and thus whether or not that physiological subsystem is functioning normally or subnormally. that is, whether or not it is diseased. So there are at least two ways, according to this objection, in which Bors's conception is value-laden. The first is in choosing the nature of the reference classes, and the second is in choosing the goals of the organism. Bors has a response to this. He says that, look, my goal is to provide a scientific, theoretical account of disease that's devoid of normative considerations and normative terminology, such as good, bad, desirable, undesirable. And you have to look through his schema and see whether there are any such value-laden terms there. And Bors says, quite rightly, that there aren't. So he talks about age, sex, and species type in the reference class section. Now, none of those terms are value-laden. And similarly, when deciding whether something is a disease, you're looking at whether something is subnormal or normal. At that stage, one is considering survival and reproduction, a subsystem's contribution to survival and reproduction. And neither survival nor reproduction are value-laden terms. So it may be the case that there is some choice involved in which goals one deems are important in the concept of pathological condition, and there may be some choice in which conditions pick out the reference classes, but none of those terms are value-laden. And Bors says, look, my goal is to come up with a lexical definition. This concept of pathological condition, it's already there, right? It's already used by doctors, it's already used by pathologists. What I'm trying to do is unpack that concept. So he's looking at what a pathological condition is, and he's using value-free terms to provide an analysis of that analysis of disease. Okay, so his concept is not value-laden. It avoids value-laden terminology and picks out a concept that already exists in medicine. If anything chooses those terms, if anything chooses the reference classes, anything chooses the goals, it's medicine itself. The second objection I'll look at is that provided by Guerrero, okay, and it's based on Peter Geach's notion of Cambridge changes. So Cambridge change is a change in a property that is not due to any change in the nature, intrinsic changes in the nature of a particular. So, an individual can be, let's say, 6'2", okay, and you remain 6'2" the whole time. Now let's suppose right now 6'2" is tall, right? So let's say the average height is 5'10". So 6'2" is tall, right? Now imagine he stays the same. He stays the same height, but everyone else grows, becomes taller, and the average height becomes 6'5". Okay, this has happened over a period of time. I mean, a few hundred years ago, people were generally a lot shorter. But now, even though I haven't changed, even though I'm 6'2", I no longer have the property of being tall, right? I'm now short. Okay, so I've changed some property. I've changed from being tall to being short, but nothing has changed. No intrinsic properties of mine have changed. Okay, I've remained 6'2". The Cambridge change objection, Guerrero's Cambridge change objection, is that if you use Bors's account, health and disease become properties subject to Cambridge changes. That is to say that somebody's health state can change. That is, someone can go from being diseased to healthy or healthy to diseased without any intrinsic changes, without their body changing in any way. And this seems counterintuitive. So imagine this. Imagine I currently have a a poor memory. Okay, in fact, you don't have to imagine it. I do have a poor memory, so I have a poor memory, but it's not that bad, right? I mean, it's pretty bad, but it's not bad. But let's suppose I just fit into that category of having a pathological condition. My memory is pathologic. Okay. Now, how do I know this? Well, it's subnormal. Okay, we've got this this curve, this distribution. And there's a range, the normal range, and I fall into the shaded category. Now imagine, for the sake of argument, that everyone in my reference class gets some infection that affects the memory. Okay, and all around me, people in my reference class, they're all getting poor memories. Even those that had really good memories before, they now have really bad memories, and my memory doesn't change, right? So although previously my memory was subnormal, I now actually have a better memory than everyone else. Given that I now have a supernormal memory, I'm no longer diseased. But my memory hasn't changed at all. So just having exactly the same memory as I had before, I've gone from having a pathological condition to being healthy, in fact being very healthy, right? Because I have a better memory than most people. And there's something very fishy about that. One response to this is just to accept it, right? Bohr seems quite content to accept it at times. He thinks that it's very unlikely that that's going to happen, okay? Not overnight anyway. You know, when was the last time everyone's memory suddenly went from being really good to really bad, right? Very, very rare occurrences when physiological subsystems, the functional efficiency of physiological subsystems changes so rapidly. And secondly, that it might actually even be necessary on the basis that, you know, what was healthy for a 40-year-old in 1500 is no longer healthy for a 40-year-old in, you know, today, and it's actually right. I mean, the standards for being healthy in 1500 were different to the standards for being healthy in 2016, and so something along the lines of health being subject to Cambridge change is absolutely necessary, as the concept of health is genuinely employed in medicine. So that's one way of dealing with the situation. Another way of dealing with the situation is by adding an extra component into the biostatistical account as employed by Christopher Boers. And that's what Peter Schwartz does. Peter Schwartz includes a negative consequences quality. So what does this mean? Well, the view is very similar to Boers's insofar as you've got your prevalence and reference class on the y-axis, and you've got functional efficiency on the x-axis. But ultimately, there's a third axis. Okay, although the diagram that he uses is in my opinion, slightly misleading. What it attempts to show is that you know, along with poor functional efficiency, often comes negative consequences. And it's only when negative consequences are great enough that you should consider somebody diseased. Similarly, of course, if the negative consequences are great enough, then you must be considered disease. So what this does, what this negative consequences line dimension does, is gives you some indication of where to draw the line. So you have your chart, your distribution, and the negative consequences line tells us how big that grey area to the left is supposed to be. Now consider the gum disease versus the hypertrichosis account again. Now, the negative consequences for gum disease are great enough for a large proportion of the population, right? So one has gum disease when one suffers negative consequences of bleeding gums and so on and so forth, and the vast majority, or sorry, not the vast majority, but just under 50% of the population suffer from those negative consequences, and thus the line is drawn almost up to the statistical mean, right? Almost up to the statistical average. That shaded area is very large. In the case of hypertrichosis, on the other hand, very, very few people have the negative consequences necessary for being diseased in that regard. So the shaded area is going to be very, very small. Really small, right to the far left-hand side, such that only 10 people have it. So bringing this back to my memory, I have a memory that's poor enough to be considered pathologic. So if you were looking at Schwarz's diagram, the negative consequences would remain high enough such that that line that demarcates the healthy from the unhealthy, that shows how large the grey section is going to be on that chart. That sticks me in the grey area. But if everyone's memory decreases as a result of this infection, then there's going to be more people suffering from negative consequences great enough to be pathologic, right? And what this does is it makes that grey area grow. It moves that line that demarcates the healthy from the unhealthy to the right. Okay, so that's Schwarz's view. Right, okay, so you see the diagram to the left. If you need to go back and make sense of all the things I've been saying, do so. But I think that's okay for today. So we've looked at Bors's view in a little more detail. We've looked at a couple of objections and a couple of responses. There are more, but if you read the text that I've given you, if you read the first two chapters of my book that's there, then that'll give you a little more material for your essays. So right about now, I'm going to be logging on to Skype, and hopefully you guys will have some questions, but maybe chat for about 5 minutes or so to sort of think about what questions you're going to ask before. All right, I'll see you in a couple of minutes.